Good morning, students. Good morning, guys. Good morning, teachers. We are going to discuss how we are going to determine or obtain the determinant of a 4x4 matrix. So in the previous video, we have discussed already how to obtain the determinants of 2x2 and 3x3 matrices. Now, this 4x4 matrix is going to be complicated, no? So, what we are going to do is we have to determine the four cases, no? Bali, we have the first, the second, the third, and the fourth. Now, what we're going to do is we're going to eliminate a row and a column, no? And see to it that there is an intersection of this row and column. Now, first is I want to eliminate the first and the first column and the first row, okay? Or the first row and the first column. Okay, so what we're going to do now is to substitute, no, here in the exponent, no, your row number and column number. So the base is constant here, -1. That is raised to 1, meaning the first row plus 1, which is the first column. Okay, so you have 1 plus 1. Now, the next thing that we're going to do is get the determinant of the remaining numbers nga which were not deleted, no, or eliminated. So, we copy 1, 0, -1. We have 1, 0, -2. Then we have -1, 0, 3. Then the next thing that we're going to do is get the determinant, okay? So, this is now getting the determinant of a 3x3 matrix. So, we follow the procedure that we have learned in the previous video. 1 times 0 times 3 times +1 is 0. Now, obviously, this will all be zeros because there are zeros, no? Nga daghan. So, we have 0 plus 0 plus 0, and so does with 1 times 0 times -1 times -1. So, it's -0. This becomes 0, and the other one also becomes 0. So, our answer is 0, the sum. Okay, so the next thing that we're going to do is substitute our values here. So, the first number that you can see, which is 1, is taken from the the intersection, no, of the deleted row and column. So, the intersection is 1. Multiplied by the product of the outcome here, which is -1 squared, and the determinant, which is 0. So you have the square of -1 is +1 times 0. That gives us 0 times 1, then that's 0. Okay, so let's proceed to the second. One thing that you should consider here is it going to be the row which will be consistent, that you do not change, no, or the column? So let's try to be consistent with the first row. That means we don't change our first row. We eliminate the first row until the fourth case. And then what we're going to change is only our columns. Okay, so in the first process, we started with the first column, and so we proceed to the second column. So we eliminate the first row and the second column so that our exponent here becomes 1, first column, first row, plus 2, which is the second row. Okay, so we have -1 to the third power or cube. Then we get the determinant of the remaining values or numbers here, or elements. So we have 5, 0, -1, 0, 0, -2, then 2, 0, -3. So the next thing that we're going to do is get the determinant of the 3x3 matrix. I hope in this case you can review your procedure in getting the determinant of a 3x3 matrix. So the result after getting the determinant of this 3x3 matrix is equal to 0. So what we're going to do is identify the intersection, which happens to be 3. Then multiply it by the product of negative 1 cube and 0. So negative 1 cube is negative 1 times 0 is 0 times 3 is also 0. Now we're consistent to the first column, so let's proceed, first row. So let's proceed to the third column. So our exponent here is the first row plus the third column, so that we get an exponent of 4. And then using the determinants of getting the determinants of a 3 by 3 matrix, then I hope you can review on that in our previous video. So the answer or the determinant is equal to 3. So the product of 3 and negative 1 raised to the 4th power is positive 3 and multiplied by the intersection, which is negative 2. And the answer is negative 6. Now for the last case, so we are again consistent with the first row. So let's proceed to the fourth column, so that we have the exponent 1 plus 4, which is equal to 5. So we have negative 1 raised to the power of 5. And the determinant of the remaining elements here, after deleting the first row and the fourth column, is 0. So 0 times negative 1 to the 5th power, which is negative 1 times 0 is 0, then times 1, that gives us 0. So we are done with the four cases. So we are now going to add up all the values, so that we can get the final answer of the determinant of the 4 by 4 matrix. So the first one, if you can remember, is equal to 0. The second one is 0. The third one is negative 6. And the fourth one is 0. So our determinant of matrix A is negative 6. Now let's try to change our procedure here. Let us try to be consistent with the third column. Or this time, we focus with the columns, So we have to be consistent with the third column, and then our rows will be changing, from the first row to the second row to the third row, then to the fourth row. So here, our exponent is the first row plus the third column. So that's why you have to the fourth. Then the determinant of the 3 by 3 matrix created by the leftovers, of the elements there in the matrix. So please review again your 3 by 3 matrix in getting the determinant of a 3 by 3 matrix. So the answer is 3. So negative 1 to the 4th power is positive 1 times 3 is 3 times negative 2. That gives us negative 6. Okay, so let's proceed to the second one. We are again consistent with the third column, so we proceed with the second row, so that our exponent here becomes 2 second row plus 3 third column. And then that becomes 5. And the determinant of the remaining values here, 1, 3, 1, 0, 1, negative 2, 2, negative 1, 3 is negative 13. So negative 1 to the 5th power is negative 1 times negative 13. It's positive 13. Multiplied by 0 is 0. We have here the third case. So again, we're consistent with the third column. So we have the third row, so that we have 3 plus 3 as our exponent here. And then we have 6. And the determinant of the matrix formed here is negative 56. So multiplied by negative 1 raised to the 6th power, which happens to be a positive 1, is negative 56. And multiplied by 0, it's 0. And the last one is, we're again consistent with the third column. So we have the fourth row. So that means the fourth row, okay, you can actually write down negative 1 to the fourth row plus the third column. Okay, so that means it's raised to 7. So negative 1 to the 7th times the determinant of the matrix, 1, 3, negative 1, 1, 3, 1, 5, 1, negative 1, 0, 1, negative 2, which is 34. So negative 1 raised to an odd number is negative 1 times 34 is negative 34 times 0, is 0. So we're done with the 4 cases. So again, we add the values that we have obtained. So you have this first one is negative 6, followed by 0, followed by another 0, and another 0. So we're very lucky with this problem because we have a lot of zeros so that it's not too difficult to do our arithmetic. All right. So we have a leftover of negative 6, okay? Or the sum of the numbers is equal to negative 6, so that our determinant of matrix A is negative 6, which is the same with our previous computation, considering row 1 to be consistent, okay? And it's our columns that are changing from 1, 2, 3, and 4. Okay? So let's have another problem and let's see what is going to be the determinant of that matrix. So suppose we're given the matrix B. So we have 1, 2, negative 3, 4, negative 4, 2, 1, 3, 3, 0, 0, negative 3, 2, 0, negative 2, and 3. Now, in this case, I would like to look at the columns and the rows, or the column and the row that contains more zeros. So, as I can see here, it's the third row and the second column. So, we have 3 plus 2. So, 3 plus 2 is equal to 5. And then the determinant of the matrix, 1, negative 3, 4, 4, negative 1, and 3, then 2, negative 2, and 3 is equal to negative 21, using this procedure. So, negative 1 to raise to an odd number is negative 1 times negative 21 is positive 21, but multiplied by the the intersection, which happens to be 0, is equal to 0. Let's have the second one. Okay, so now I would like to decide whether it's going to be the column or the row that I want to be consistent. So in this case, I decided to make the third row to be consistent. So I'll go back to column 1. So ray 3 plus 1 is equal to 4, and then the determinant of matrix 2, negative 3, 4, 2, 1, 3, 0, negative 2, 3 is equal to 20. And so, negative 1 raised to an even number is equal to positive 1. And so you have 1 times 20, which is 20, times 3 is equal to 60. Okay, we have now the third case. So we're consistent again with the third row. So let's proceed to the third column. So that you have 3 plus 3 and the exponent is 6. Again, negative 1 is raised to an even number. So it's equal to positive 1 times 26 is 26 times 0 is equal to 0. And lastly, okay, by the way, this is 0 because that's our intersection. Okay, now let's proceed to the fourth case. Again, we're consistent with the third row, so let's proceed to the fourth column. So we have 3 plus 4, which is 7. And then the determinant of the matrix 1, 2, negative 3, negative 4, 2, 1, 2, 0, negative 2 is equal to negative 4. So negative 1 raised to an odd number is negative 1 times negative 4 is positive 4 times negative 3, which is the intersection. Okay, so which is negative 3, and the product is negative 12. So we're done with the 4 cases. So let's now add the outcomes. So 0, 60, 0, and negative 12 when added is equal to 48. So the determinant of matrix B is equal to 48. So we're done with the discussion of getting the determinants of a 4x4 matrix. I hope you learned a lot today. This is Dr. Batukan saying, mathematics is easy to learn when one learns with enthusiasm. Bye!